purpose of this video is to go over the distributive property in like terms. This is the worksheet that was handed out in class. I'll also post solutions up on Blackboard in written form. So the instructions say to simplify each expression. So overall what we're going for is being able to write all of these expressions without using any form of parentheses and making sure that all of our like terms are combined. What we have to look for is the distributive property in most of these. So the distributive property says that if we have A times the quantity B plus C, where A, B, and C are all real numbers, then we could always rewrite this as A times B plus A times C. So this A we can distribute to B and we can distribute to C. We're allowing ourselves to ignore the order of operations as long as we do it in the correct way. And we'll always end up with A times B plus A times C. And this is something that we actually have to assume whenever we create the real numbers. It's not something that we can actually go through and prove, but it is something that will always be true for the real numbers. So we're going to start out with 3 times the quantity 2x minus 5. And a lot of times what people will do, and what I'm about to write is incorrect, it is not 3 times 2x minus 5 like so. We cannot simplify it to 6x minus 5. This is the wrong way to go. So instead we have to use this distributive property, and we're going to distribute 3 to the 2x and 3 times 5. So 3 times 2x, that will be 6x, and then 3 times 5 is going to be 15. And we have a subtraction sign in between them, so that subtraction sign is just going to come down. There is a reason why the subtraction sign comes down even though there's an addition sign up here. I'll talk about that in a later example. So this is 6x minus 15. The next one, we have negative 9 times negative 2a minus 3a. There are a couple ways we can go about doing this. The first way is to simplify the like terms before we even start. If we simplify the like terms before we even start, we don't need to use the distributive property. We notice, first off, that negative 2 has an a next to it, and this subtraction of 3 also has an a along with it. And because both of these are a's, it's like saying I owe a person 2 apples and I owe a person 3 apples. How many apples overall do I owe? Oh, I owe 5 apples overall. So I'm taking this negative 2a, subtracting 3a, that gives me a total of negative 5a. And then if I multiply negative 9 times negative 5a, what that gives me is a positive 45. A negative times a negative is a positive. 9 times 5 is 45, and then I have a just along for the ride. Another way I could go about doing this is not starting out with the simplification process, instead starting out with the distributive property. So this way we're using the distributive property. I'm going to take this negative 9 and I'm going to multiply by negative 2a. When I multiply negative 9 times negative 2a, I would get a positive number. It would be a positive 18, and then if I multiply that by a, I get an 18a. And then I am subtracting, so the subtraction sign gets carried through, minus, and then I take negative 9 and I still multiply it by 3a. So I'm multiplying it by 3a right now, and I've already used the subtraction sign so I don't have to worry about that. Negative 9 times 3a would be a negative 27a. I could have also written this as negative 9 times negative 3a. That would give me plus a positive. Overall, it's going to give me the same thing. In fact, let me simplify this. Minus a negative. That is the, so subtracting a negative is the same as adding a positive version. So I would write plus, and then I have 27a. If I have 18 apples and 27 apples, altogether I have 45, and again, apples. So in either case, I would end up with 45a. The next one, 7v times v squared plus 8v minus 10. Now whenever you have a v or some other variable, you have to be very careful about your powers. Make sure that you are simplifying your powers correctly. So we're going to distribute this 7v times v squared, and I'm going to do each of these in a different color this time. 8v is having 7v distributed to it, and then I also have 7v distributed to 10. Now 7v times v, that would be 7v times v squared. Let's see, 7 is going to be there for sure. V times v squared is not just v squared, and it's not just v. It is v times v, or v to the third power. So v times v squared is v to the third power. And then I'm adding, because I have this addition sign right here, I'm adding 7v times 8v. If I take 7v times 8v, that would give me 56v squared. V squared, not just v. And then finally, if I take 7v and I multiply by 10, 7v times 10 is 70v. And then I also have this subtraction sign because I had a subtraction sign right there. Now on this one, the reason why, let me explain on this why this negative, this subtraction sign can be interpreted, is just brought down. What I did was I took 7v times, and I can rewrite this entire thing actually. So if I rewrite this, I'll rewrite it in red over here. 7v times v squared plus 8v plus a negative 10. And if I add a negative 10, that's the same as subtraction. That's actually the definition of subtraction. When I add the additive inverse of 10, that is the same as subtracting 10. So this would be 7v to the third power plus 56v squared, and then I'm adding 7v times negative 10 would be negative 70v, and then adding a negative is the same thing as subtraction, so that would give me 7v to the third power plus 56v squared minus 70v. So even though I have addition written up here, the same thing extends to subtraction. I could also write this: a times b plus, a times b minus c is equal to a times b minus a times c. And that will always be true as well. On the next one, I have z squared on the outside. So z squared times the quantity negative z squared minus 14z plus 10. I'm going to take this z squared and multiply by negative z squared, and I would get a negative. This is a positive times a negative. That gives me a negative. Z squared times z squared. If I multiply two things with the same base, they both have a base of z, then that will give me a z as a base, and then I add the exponents. 2 plus 2 is 4. So this would be negative z squared as my first term. The next thing that I have is minus 14z. So I'm going to have a subtraction sign again because I have a subtraction sign right here. Z squared times 14z. So that's going to give me a 14. Z squared times z would be z to the third power, and then z squared times 10 would be 10z squared. And I do have an addition sign right here, so I should have a plus sign. And then this is simplified. We're done with this one. On the next one, negative x is being distributed to 5. So negative x times 5. A negative times a positive would be a negative. I have a 5 and an x, and I list out the coefficient first, so the coefficient on my final answer will be a -5, and then I have an x, and then I'm subtracting 13y squared. So if I multiply -x times 13y squared, I'm still going to carry through this negative sign, so that's going to be subtract. -x times 13 would be a -13, and then x times y squared would be x times y squared. Then I take this -x and I distribute it to 9, and I still have this plus sign around, so plus -x times 9 would be -9 times x. So I take a negative times a positive, that will give me my negative sign. X times 9 is 9x by definition. And then what I would do afterward is just a little bit of cleanup. I have a -5x. If I subtract a negative, that is same as adding. So subtraction is same as adding the opposite. The opposite of -13 would be a positive 13. And I still have xy squared. And then adding a negative, by the definition of subtraction, I would be subtracting 9x. And then I'm going to combine some like terms. So now I can look at my like terms. I'm going to underline this one way. This is not just x, this is x times y squared. So even though there's an x there, it's a little bit more complex than that. And then this one over here, I still have x's. So the x's I can combine together. If I have -5x and -9x, if I add the coefficients, I get a -14x plus 13xy squared. And then when I arrange this in descending order of powers, this x is much less complex than x times y times y. So I'm going to list out 13xy squared minus 14x. And here I'm adding these two. By the commutative property, I'm adding a -14x. By the definition of subtraction, that's the same as having subtraction of 14x. So this one is finished. 13x times y squared minus 14x. And this is the last one that we'll do in this video. I noticed that this 3b is written on the right side. By the commutative property, I can see here's one of the things that I'm multiplying, and then here's the other part that I'm multiplying. So each of those factors I can switch around, and I can write 3b on the right side if I want to, and then I would write 12b minus 3b squared plus 14 minus b squared. So I can see that it doesn't actually matter if I rewrite this or not. I could have distributed this at the very beginning. I would have gone this direction with it. So I would be distributing this 4 times. You might also want to take note that some of these things can be combined. There are some like terms. Here's a like term with this one over here. These b squareds can be combined. I could combine this to -4b squared, but I'm not going to do that. I'm just going to distribute. There's no particular reason why I'm doing this. I could just choose whichever way I wanted to. So I'm just choosing to distribute first. It will not make a difference for my final answer. You should get the same thing no matter which way you do this. I am going to have 4 distributions that I'm going to do. If you combine these like terms, you will only have 3. So I would get 36b squared minus 9b to the 3rd power plus, and then this would be 42b minus 3b squared, b a 3rd power, excuse me. And then I can combine this right here and this right here. Those are like terms. This is b to the 3rd power. And I would get -12b to the 3rd power plus 36b squared plus 42b